have here a problem to do with conic sections. We have a parabola and there is a tangent of the parabola which goes through the line 16a, 17a. The tangent is at the point P, x1, y1, and the parabola has the equation y squared is equal to 4ax. The question asks us to find out what the equations are of the tangents to the parabola, where the tangents go through the point 16a and 17a. So this is telling us immediately we are looking for 2 points. I wanted to do this question as conic sections are intrinsically interesting and they're also a bit tricky to work with. And I wanted to show you how we can solve problems like this and the various processes that we go through to get to the answer. Okay, so looking at it, like many problems of this type, it's a case of deriving two equations for the same property. In this case, it is the equation of the line, or more specifically, it is the gradient of this line here. Okay, so on the parabola, y squared equals 4ax. Okay, at any point y1, x1, the gradient is given by implicitly differentiating the equation of the parabola. So that gives us 2y dy over dx is equal to 4a. Okay, so that tells us that dy over dx is equal to 2a over y. In this case it's going to be y1 that we're going to be plugging into the equation. So in terms of the formula for the parabola, that is what the gradient is at this point P. So at the point P on the parabola, our gradient is 2a over y, or 2a over y1 here, y1. Okay, now to find an alternative expression for the gradient, we go back to our GCSE maths, and what we say is we've got a point here, and this point here runs from Q to P down there like that, and we want to find this gradient here of the line that runs like that. Okay, so we just draw a line here. Okay, and we can see here that the gradient of this line is going to be the gradient of that line running PQ is simply going to be the y1 minus 17a. So you've got y1, 17a, so you've got difference between y1 here and 17a up there. So you're here and here, divided by x1 minus 16a, like that. Okay, and that is equal to the gradient of the line PQ. And it's also equal to, surprise, 2a over y1. So what do we do next? We multiply it through. So you multiply this side, the y1 up there, so you've got y1 squared minus 17a y1 is equal to 2a x1 minus 2a times 16a is 32a squared. Okay, right. Here we know that y squared is equal to 4ax. Okay, so y1 squared is equal to 4ax1. Divide both sides by 2. y1 squared over 2 equals 2ax1. We have 2ax1 here, so we need to substitute y1 squared divided by 2 into this equation so that we can put the whole of this line into terms of y squared. So we're eliminating the x. So that's going to give us y1 squared minus 17a y1 is equal to y squared, y1 squared over 2 minus 32 a squared. Box that off neatly. And then let's write this out here. We're going to multiply by the 2 on that side to get rid of it. Get rid of the fraction of 2 on the right hand side. So that gives us 2y1 squared minus 34ay1 is equal to y1 squared minus 64a squared. And let's just take that entire equation and put it in terms of the y1 squared. It's 2y minus y1 squared is equal to y1 squared minus 34ay1 plus 64a squared equals 0. Okay, so that is a quadratic equation in y. y1 squared minus 34ay plus 64a squared equals 0. Now that itself might look a bit scary, but don't worry about it. Let's just write it out here as if we're going to factor it. We know as that's a plus, that's a minus. As this is a plus, the signs are the same, so they're going to be both negative here. And then we've got y1 minus there like that. Looking for two numbers. They're both negative because that's a plus and that's a minus. That's a plus, so it means they're both the same, and that's the minus, it means they're both negative. The two numbers added together come to minus 34, multiply them together come to 64. And it doesn't take an awful lot of brain work to work out that the numbers we're looking for are 2 and 32. Because minus 2 minus 32 is minus 34, minus 2 times 32 is 64. And don't forget the a, because we've got minus 34a and 64a squared. Okay, so that's 2a times 32a, 64a squared. 34, 2a minus 2a minus 32a is minus 34a. Okay, so y1 is either equal to 2a or y1 is equal to 32a. Okay, cool. We know that y1 squared is equal to 4ax. So y1 is equal to 2a. So 4a squared is equal to 4ax, and so x1 is equal to, x1 is going to be equal to 4a squared divided by 4a, which is equal to a. So where y1 is equal to 2a, x1 is equal to a. And if y1 is equal to 32a, y1 squared is equal to 4ax. 32 squared is, of course, 1024. y1 squared equals 4ax. And here in this case, x is equal to 1024a squared divided by 4a. Oh, that's really messy, isn't it? Sorry about that. So we've got 1024a squared y1 to 4a squared over 4a is equal to 256a. So that's our x1. Okay, right. So a quick recap. We've got the 2 points of intersection with the parabola. There are tangents at y1 is equal to 2a and x1 is equal to a. That looks rather like a 9, doesn't it? And then we have another tangent at y1 is equal to 32a and x1 is equal to 256a. There. Right, so what we need to do now is we need to find the equation for the lines. And it's the same method that we've been doing since we were at secondary school or high school. So the first case, we've got y minus y1, which is going to be 2a, is equal to the gradient. The gradient, as we know, is right up here. So it's 2a over y1. So it's 2a over y1, which is 2a. multiplied by x minus x1, which is equal to a. It doesn't take much to work out that that is going to come to y minus 2a equals x minus a, or y is equal to x plus a, as you add 2a to both sides, putting y on the left hand side, and adding 2a to minus a gives us a. So that is the equation of the first tangent. The equation of the second tangent follows thus. You've got y minus y1 is 32a is equal to, there we go again, your gradient is 2a over y1, which is equal to 2a over 32a, x minus 256a. Don't worry, bear with, you'll be alright. Multiply through by 32a, so we've got, in fact we don't even need to do that, we can cancel the a, and that comes to 16. So it's going to be 16y minus 32a times 16 is 512a equals x minus 256a. Okay, so on this side we've got 16y is equal to x minus 256. We're adding the 512a to this side. We add the 512a to this side. So that gives us x plus 5. No, it's not x plus 256a. And that is the second equation of the tangent that comes from 16a, 17a. So there they both are. And as we could see up here, we have one tangent that would necessarily be around here, and the other one, as it's at the points of 32a and 256a, it's going to be way up this area. So you can see with this working here, we've got the gradient first of all that's taken from the equation of the parabola. We then work out what the gradient is for the line, always with reference to this point. You equate the two, so we've got the line, gradient to the line, equated to the gradient of the parabola. Comes up with a quadratic equation. Substitute where necessary to put it in terms of just one variable of y1, or y1 squared, and y1 and y1 squared here. Factorise it to come up with the values for y1 and y being 2a and y1 being 32a. Use the equation of the parabola, y1 squared is equal to 4ax, to work out what x1 is, but in both situations being a and 256a. And then work out the equation of the line, using, of course, y minus y1 is equal to mx minus x1. That Hardy equation. There you go. There are the two solutions for the tangents on the parabola that go through the points 16a and 17a. How cool is that?